Coming up on Destination Tomorrow, NASA is preparing new Mars exploration missions that might help explain many unanswered questions about the red planet. Plus, a new device developed at NASA will give parents a second set of eyes, keeping their children safer. And we meet a retired NASA engineer whose revolutionary design helped launch America into the space age. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
In the near future, NASA is planning a series of new Mars exploration missions aimed at finding out more about the red planet. Newer, larger, unmanned rover vehicles will be able to travel much farther than previous missions, acting as geological surveyors, exploring the surface of Mars.
NASA planners expect to land 2 identical rovers in different regions on the planet's surface. The twin rovers will be exploring Mars' climate history while searching for organic materials and signs of water and life.
Tonya St. Romain finds out more about NASA's new Mars rover and its incredible journey to the red planet.
For hundreds of years, humans have dreamed of exploring the planet Mars. One important reason for this is that, other than Earth, Mars is the planet with the most hospitable climate in our solar system. The climate on Mars is so hospitable, in fact, that many scientists believe that liquid water may have once flowed over its surface, harboring primitive bacterial life. In an effort to investigate these intriguing possibilities, NASA's planned several new Mars exploration missions. NASA planners hope these missions will help explain many unanswered questions about the red planet and how those answers will affect us here on Earth. I spoke with Prayson Desai from NASA Langley Research Center to find out more.
In mid-2003, 2 Mars exploration rovers will be launched to explore the surface of Mars. You may remember the Pathfinder mission from a few years ago. These are very similar, but have some major differences. The Pathfinder mission had a lander, which acted as a base station, and a small rover, which was about 1.5 feet in length. The 2003 rovers have many more instruments and will be able to traverse much longer distances on the surface of Mars. These new rovers will act like mobile field geologists. This mission is actually very exciting compared to previous missions. For the first time, the rovers will be able to go much greater distances away from the lander, and for the first time we could also go to a hill on top of it and see what's over it. And so we would be able to cover a lot more different areas and see different geological features to try to get a better understanding of how Mars is evolving in those regions.
Prayson, what's the process of getting the rovers to Mars?
Well, Tonya, the rovers will be launched on Delta rockets in June and July of 2003. The rockets will provide the appropriate speed needed to get the spacecraft to go to Mars. The spacecraft consists of a crew stage, which supply the communications and power during the 7th-month journey to Mars, and a lander, which has the rover inside it. Upon arrival at Mars in January 2004, the landers are separated and enter the Martian atmosphere.
Once the lander enters the Martian atmosphere, the aeroshell design will slow the entry from 12,000 miles per hour to about 900 miles per hour. A parachute will then deploy, further slowing the spacecraft. Then, airbags will inflate around the craft to cushion the landing. About 600 feet above the surface, retro rockets will fire, slowing the craft even further. Once the spacecraft stops rolling, the airbags will deflate and pedals will open up, bringing the lander to an upright position. Since the rovers carry all of their instruments on board, they'll be able to start exploring the planet almost immediately without having to stay close to the lander. How will the rovers be commanded? Will they be driven by remote control from Earth?
Actually, the controllers from the Earth will only command the rovers to specific soil and rock targets. It'll be up to the rovers to find their own way to get there. The reason we have to do this is because the signal from Earth takes too long to get to Mars to have us operate them by remote control. As a result, the rovers must be able to operate autonomously. We will decide based on the information we get from the cameras and instruments that are sitting on the rover where are good sites to go to, and then command the rovers to go there. We hope the rovers will be able to travel up to a half a mile from the landing site.
Okay, so once a rover gets to a rock of interest, how will it examine it?
The rovers have many different instruments on there that allow us to examine the rocks down to the microscopic level. Once we analyze this type of information, we can tell a lot of different things about the rock themselves, like their mineralogy, elemental chemistry, their surface texture. This type of information will give us evidence of ancient environmental conditions and the possibility of some type of biological activity occurring.
Recent satellite images of Mars show geologic features like channels, which support the theory that liquid water once flowed over the surface. Today, the Martian temperature is too low and the atmosphere too thin for liquid water to exist on the surface, but many scientists believe that liquid water may still exist below the surface of Mars, where temperatures are not as harsh. If the rovers find convincing evidence of liquid water on Mars, then it's also possible they may find proof of life on Mars as well.
There's a lot of evidence that there's frozen water just below the surface of Mars, and a lot of these missions that we're trying to go to Mars in the next few years is trying to get a better understanding of how much water is there, and is it in the liquid form near the surface somewhere. 3 billion years ago, Mars and Earth were very much alike. Mars was at that time much wetter and much warmer than it is now, and something has happened. So by trying to get a better understanding of how Mars's environment has evolved, it will give us a better understanding of potentially how the Earth's environment would evolve and give us an idea of how it's going to change in the future.
So by studying Mars, it may be able to tell where our future is headed on this planet?
Exactly. The reason we are exploring Mars, and other places in the solar system for that matter, is to help answer two fundamental questions. One, to explain the formation and evolution of our solar system and the Earth within it, and two, to seek the origins of life and its existence beyond the Earth.
During the next decade, Mars will be the solar system's most popular travel destination. There are plans for nearly a dozen Mars missions being planned by 3 countries, the United States, Russia, and Japan. Coming up, a new device developed by NASA might help parents and caregivers keep an electronic eye on their children. But first, did you know that the Viking 1 spacecraft was the first craft to land on the Martian surface on July 20th, 1976? With its companion craft, Viking 2, the 2 landers analyzed atmospheric and weather conditions, collected soil samples, and took over 56,000 pictures of the planet's surface.
Unfortunately, in recent years, there has been an alarming increase in deaths of infants and small children after being left unattended inside a vehicle. A new device developed at NASA may help to stop this disturbing trend from growing further. Inspired by aircraft flight test technology, the Child Presence Sensor has been designed to help prevent these tragic deaths from ever occurring again. Jennifer Pulley finds out more.
According to a national nonprofit safety organization called Kids in Cars, 81 infants and small children died last year while being left unattended in and around a vehicle, up nearly 100% from the previous year. In many cases, parents simply forget they've left their children unattended, while others leave their children in a car for a few minutes to run errands. Unfortunately, leaving a child in a car for even a short time can end tragically because temperatures inside a car can soar or plummet in just a matter of minutes. In an effort to combat this deadly problem, NASA has developed a safety device called a Child Presence Sensor. This sensor alerts parents who inadvertently leave their children strapped in car seats. I spoke with Chris Edwards of NASA Langley's Laser Systems branch to find out more about this fascinating innovation.
Well, the inspiration for the child safety sensor came from an incident that happened that I read about where a child had died from being left in a vehicle. I really wanted to develop a technology that would prevent this from happening, sort of a second set of eyes and ears. And I looked at technology that was out there and realized there really wasn't any. There's nothing a consumer could purchase to prevent that from happening. I looked at how the incident occurred and then realized that that could really happen to anybody, being that a change in routine, something like that. It's usually a series of events that happen. I really wanted to break that chain of events. So we decided to go ahead and form a team Terry Mack of Lockheed Martin, Ed Milan of Langley, and develop the technology and make it affordable and easy to use for the average person to be able to just install it in any car seat, in any vehicle, and give them and that child a second chance.
This is how the child presence sensor works. A thin sensor is placed between the cushion and the frame of the baby seat. The sensor, or switch, has a large activation area with a sensitivity of about 8 ounces. Attached to the switch is a transmitter that mounts on the baby seat. The sensor switch triggers immediately when a child is placed in the seat and deactivates when the child is removed. The sensor will detect weight once the child is placed in the seat and transmits a unique code to a keychain alarm module with a corresponding radio frequency. If the driver moves too far away from the vehicle, a small alarm built into the keychain sounds 10 warning beeps. If the driver doesn't return within 1 minute, the alarm will beep continuously and cannot be turned off until it is reset on the transmitter. How did NASA contribute to the development of this child safety device?
At NASA, we have a 757 aircraft as a flying laboratory that we use for aviation safety. And they have an experiment on there that takes data that dealt with the stresses on the landing gear and transmitting that data back into the aircraft with a radio frequency link. And we took a similar approach with the child safety sensor, in that we monitor if the child is in the seat, and we send that data to the receiver, which is on the keychain that a driver would hold. So we were able to use that technology and it inspired us to develop the child safety sensor.
So what are your hopes for the future of this invention?
Well, the main goal is to save lives. We're currently seeking commercial partners to license the technology. We've designed it to be inexpensive. It'll cost, it depends on how many units are produced, but certainly the $20 to $30 range is reasonable. And that's what we're currently shooting for. So if we can get a commercial partner, a lot of the technology, most all of it's been developed, so it should go to market fairly quickly. When I started this, I really wanted anybody at a department store or whatever to come and be able to pull this off the shelf, put batteries in it, place it in their car, and provide that second chance.
Today, most of us take the idea of manned spaceflight for granted. But during the late 50s and early 60s, the idea of manned traveling in space was an exciting challenge to be conquered. In the early days of the space program, engineers knew very little about the effects of space travel and re-entry into the atmosphere. But one man, Dr. Max Faget, came up with a revolutionary design that helped launch America into the space age. During the late 50s, engineers debated over which type of craft should be used to launch man into space. The debate centered on whether the U.S. should continue refining the X series of rocket planes or to build an entirely new type of craft to achieve orbital flight. While this debate was occurring in the U.S., the Russian space agency successfully launched Sputnik, the first satellite into space, in October of 1957. The space race had begun, and the U.S. was already far behind. After hearing about the successful flight of Sputnik, engineers began to design and test new spacecraft at a frenetic pace. The U.S. had some expertise in building long-range ballistic missiles, but was having difficulty designing a vehicle to carry man into space and bring him back safely. One day, while playing pinochle after lunch with a coworker, engineer Max Faget began sketching out a design for a new spacecraft on his napkin. This new craft had a blunt-shaped bottom and was designed to fit on top of a ballistic missile. With his idea in hand, Faget began a series of crude experiments to test his design, one of which included tossing a paper plate out of a window to test the basic aerodynamic principles of the design. Faget's idea for a blunt-shaped craft was ill-received by many aerodynamicists of the time. Researchers thought the most effective way to orbit and return to Earth would be in a low-drag aerodynamic vehicle. Although this vehicle had merit, Faget knew that an aerodynamic aircraft would create excessive amounts of heat, causing major structural and safety problems for the astronauts.
Well, everybody that had to do with anything with flying through the air would always try and keep the drag down as much as they could. So the original versions of ballistic missile reentry vehicles were all highly streamlined, and they had everybody working on ways to keep them cool.
Faget alternatively proposed that his new blunt body design should be used instead. He reasoned that his design would create a huge shock wave around the spacecraft, moving the heat away and keeping the craft cooler upon re-entry. Faget began to push his idea as the best one to get the job done quickly and safely.
That particular shape, it wasn't really an invention. That's just a piece of nature. There isn't any shape that will have less heating than a Mercury shape. It's it.
After a series of wind tunnel tests, his blunt-shaped vehicle was proven to be the most successful design. Faget's space capsule design was adopted in the late 50s. Astronaut Alan Shepard became the first person to fly in the Mercury spacecraft designed with a blunt shape. This design proved to be so successful that a variant of this craft was also used in both the Gemini and Apollo space programs. Faget's foresight and tenacity overcame many technical challenges and helped launch America into the space age.
Dr. Faget not only designed the Mercury spacecraft, but he also played a major role in designing virtually every U.S. crewed spacecraft since that time, including the Space Shuttle. Coming up, Destination Tomorrow looks at revolutionary new concepts in micro-vehicle designs being developed by NASA. But first, did you know that the first Mercury flight, Freedom 7, was not Alan Shepard's only flight into space? Shepard also commanded the Apollo 14 flight on February 5, 1972, becoming the 5th man to walk on the moon and also the oldest at age 47.
In recent years, a goal of many researchers has been to develop products that can not only improve safety, but also save money. Researchers in the Small Unmanned Aerial Vehicle Lab, or SWAV lab at NASA Langley, have been working on revolutionary micro-vehicles that have been designed not only to save money, but also to save lives. Derek Leonidov explains.
Unmanned aerial vehicles, or UAVs, may look like typical toy airplanes, but this technology should not be taken for granted. UAVs are being used for a variety of different tasks, including law enforcement, search and rescue, and specific military operations. Currently, researchers in the Small Unmanned Aerial Vehicle Laboratory, or SWAV lab, at NASA Langley are developing unique UAVs to perform in high-risk situations that may be too dangerous or costly for humans. I spoke with Mike Logan at NASA's Langley Research Center to find out more.
Primarily what we're trying to do is solve problems for people. They will come to us with a particular problem, and we try and design and develop a small airplane to help solve that problem. In some cases, we may use brand new technology that we're developing here at NASA to incorporate in these small airplanes that help us to solve those problems. So they can come to us where they wouldn't be able to go anywhere else and get those problems solved.
So what kind of configurations do UAVs come in?
Well, as you can imagine, different problems require different solutions. For example, we had a group come to us and wanted a backpack observation vehicle where it could fit into a backpack. They could take it out, unfold it, and toss it in the air and fly it. It would radio back video images. In this case, the wings fold underneath, and this fits into a 15 by 15 by 5 inch box. Very light, very compact. We also test configurations before we actually make a flying model. This is a wind tunnel model of a small single-seat general aviation aircraft that we call the Channel Bug. It has these unique configurations called channel wings, and it lets this vehicle take off and land in a 50-foot runway. And of course, if you want it even smaller, then we have a smaller vehicle that would be capable of flying into a building.
And how is one of these created? What's the process that goes into developing a UAV?
Well, the first thing we do is we try and analyze the problem, and we use a lot of computer-aided technologies to help us with that. Once we get a design that we're happy with, then many times, for example, this is a mock-up of that same configuration. It was done using a process called stereolithography, where the computer divides up this model into little slices. It traces each slice onto a vat of photoreactive resin that hardens it. It builds it slice by slice, and then it comes out as a solid piece. So we can take this mock-up to make sure that it's going to be the right size and shape that we want, and then we can turn it into a flying vehicle by using those same CAD files, milling a mold to make the little skins for this vehicle, and turn it into a real airplane, similar to what you see here.
So what are some of the advantages that a UAV has over a regular piloted aircraft?
Well, there's actually a number of advantages that UAVs have over piloted airplanes.
One of which is the ability to fly lower, longer, and into more hazardous airspace than any pilot would dare. Much like robots are used to handle explosives in many police or SWAT situations, the UAV can be placed in high-threat situations, perform exceptionally, and complete its mission with little or no risk to human operators. With advances in audio and video electronics, real-time television images are possible to help guide a pilot around dangerous situations or gather valuable intelligence.
One of the problems we were presented with was a problem of trying to look at what's inside of maybe a partially damaged building. For example, in the case of an earthquake, you really don't want to risk a whole team of people going into that building, but you'd like to know if there's someone inside that you need to go rescue. So when presented with this challenge, we worked up a little prototype. That's what you see here. This is a little vehicle that would carry a camera. It takes off vertically. This is what's called a VTOL, or vertical takeoff and landing. Takes off vertically, wings pitch forward for forward flight, but then when it needs to hover, it can stop and hover. It can turn by moving the wings differentially. It can be flown by remote control by using a display that actually shows the picture of the camera in the nose. So you fly it remotely from the camera.
All without risking the pilot or anyone remote controlling the vehicle.
Correct. Another problem that we're looking at is trying to use these small unmanned air vehicles to detect forest fires. That's clearly a big problem. Finding and fighting forest fires now is very, very expensive.
The average cost of fighting forest fires in the United States is over $800 million a year. One reason that fighting forest fires is so costly is that by the time many fires are detected, they are already unmanageable. Although 98% of all forest fires are caught and extinguished quickly, it's the 2% that turn into wildfires, costing taxpayers millions. This is where the idea for the UAV comes in. The plan is to place hundreds of these low-cost UAVs on current or abandoned forest fire lookout stations around the country. The vehicle would remotely take off, land, and recharge autonomously up to 6 times a day from the lookout tower. It would travel over a section of the forest and use onboard sensors and cameras to detect smoke. If smoke is detected, it would send out a warning message to the Forest Service with the exact GPS coordinates pinpointing the fire. This would enable firefighters to respond much faster, potentially reducing firefighting costs dramatically.
So Mike, what does the future hold for UAVs?
Well, we're looking at a whole range of activities and things that these small airplanes can actually do beyond just saving money, but defending our country, saving lives, solving problems. That's what the SWAV Lab is all about.
Flight simulators are valuable tools in helping pilots and engineers test new ideas and new systems in aircraft. Simulators continue to improve aircraft safety and benefit the entire aviation industry, not just one pilot.
These complex machines display extremely accurate representations of the aircraft controls and the environment around them. But how does a modern flight simulator work? For some answers, we turn to Johnny Alonso.
One of the most effective tools pilots and engineers use when learning about aircraft is the flight simulator. The simulators have been around almost as long as airplanes have. In fact, in early models, pilots would practice flying by sitting in wooden barrels suspended off the ground. The simulators have come a long way since then, but the basic idea of making flying safer hasn't changed. Today, they are incredibly complex machines that are used not just to help pilots learn to fly, but are used to run experiments or tests, which can be too expensive or too dangerous to attempt in flight. I spoke with Marshall Smith at NASA Langley Research Center to find out how they work. So Marshall, what are the differences between NASA flight simulators and other simulators?
Well, the difference between NASA flight simulators and other simulators are mainly in the training environment versus engineering and research. Other types of simulators are used for training, and so they benefit one pilot or the pilots that are out there learning to fly airplanes, but our simulators are used for developing engineering concepts or things that make flying safer.
So what are some real-world problems that simulators have solved?
Some of the problems are related to safety. For example, wind shear detection and avoidance was a big problem. Wind shear occurs when you have a real strong downdraft, and it could occur from thunderstorms or could occur near mountainsides or even in clear air. But basically what happens is it causes the plane to lose lift and crash. And 15 to 20 years ago, a lot of planes were crashing because of wind shear problems, but engineering simulators were used, at NASA particularly, to detect wind shears, and also give them guidance as to how to get out of a wind shear condition and actually land the plane safely. Wind shear is rarely a problem anymore.
So that was like 15 or 20 years ago. What are some current things that you're working on today?
Okay, some of the problems we're working on today involve synthetic vision, where we're trying to give the pilot an out-the-window picture of what the world looks like if he can't see. It's flying through clouds or it's really low visibility. He can look down on this display and see what he would see if there was clear air outside of him. Other things that we're working on are keeping planes properly spaced apart if they're doing parallel approaches or on the ground. If planes are taxiing around and air traffic control inadvertently tells somebody to go in front of a plane, he has another method where he can determine something bad is happening.
So how have simulators changed over the years?
Over the past 15 to 20 years, simulators have changed dramatically, and that's largely due to the computer revolution and changes in graphic systems from the entertainment industry. These simulators have gotten much more accurate and detailed, the simulations themselves, to the point that we can do a simulation and then go out and fly the real aircraft and really find no differences in the two.
So are pilots the only ones using flight simulators?
Well, absolutely not. Actually, our simulators are used by researchers who are engineers and technicians who are developing all of these programs so that we can determine whether they'll be good for the aviation industry or not. And then pilots are brought in actually at the end of the program so that they can be used as test subjects to determine whether the information then is going to be good enough to take onto the airplane for further test. Pilots also help us develop the test as well.
So Marshall, can you show me how the simulator works?
Sure. We're actually at Dallas-Fort Worth right now, and we're going to take off from Dallas-Fort Worth, and you're going to do it for us. So you take your throttles,
give it a try.
Move them all the way forward, your flaps are already set, and you're ready to go.
Start with this, right?
There we go.
All right.
And as your airspeed gets up to about 150, okay, you can pull back. Go ahead and pull back. There you go. All right, now you can push forward a little bit. And you just took off.
This is amazing.
If it's in the real aircraft, it's in this simulator. This particular simulator is a copy of our 757 aircraft that we have at NASA that we use for research. It's a copy of the forward nose section. So we actually have, if we have a particular research instrument in the aircraft, we'll put it in the simulator as well.
You guys must have fun working up here.
It's a blast.
Look at me saying up here. We're nowhere. This is cool. Thanks a lot, Marshall. This has been so much fun.
It's been my pleasure. You can come back anytime.
Thank you. I will. I just have one question.
Okay.
Where do I put the quarters?
Oh, that goes right over here.
Yeah? You got me?
That's all for this edition of Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.